Okay, exploring graphs of sinusoidal functions. So, definitions. Periodic function, a function whose graph repeats in regular intervals or cycles. Midline, we've talked about some of these. The horizontal line halfway between the maximum and minimum values of a periodic. It's like the spell checker doesn't work or something. Amplitude, the distance from the midline to the maximum or from the midline to the minimum, or half the distance from the maximum to the minimum, right? So it's either this distance here or this distance here or half of that distance there. The period is the length of the interval of the domain, which means the x values, to complete one cycle, or it's the length of one cycle. So we really want to become familiar with the basic sine function. And this is the basic sine function when it's expressed in degrees. Okay, so we're going to do a little bit on degrees. Mostly, you're just going to do radians. So I'm going to go, in sense, we'll do a little bit beyond maybe what you have to know. And we'll also look at the cosine function. The book goes into, again, more detail than what you really need to know. But it doesn't hurt to see the stuff. So here's the basic sine function. It basically starts at the midline. Here's the midline here, right? So what's the equation of the midline? Y equals 0. What is the amplitude? What's the distance from the midline to the maximum? 1. What is the period? How long does it take to do one complete cycle? 360. Okay, in this case, degrees. So your basic sine function works like this. This is the way I think about it, right? It starts at the midline and it's going up. Its period is 360 degrees and it's split into 4 parts. And the 4 parts are from the midline to the maximum, from the maximum back down to the midline, from the midline down to the minimum, and from the minimum back to the midline. Okay, so that's 4 parts. Since the period is 360 degrees, each of those parts will be 90 degrees, right? 360 divided by 4 is 90. So in the first 90 degrees, it climbs up to a maximum. In the next 90, it drops back down, and then so on. Yep. Period is x. It's the domain, right? Domain is the x values. Amplitude is a y value. Midline is a y value. Here's an equation, 3 sine 2x. Okay, now we looked at this the other day, right? Just in the intro and saying things are going to change. So what's the equation of the midline for this?
1.
Y equals 0. What's the amplitude? 3. Okay, so you see that matches up with that. What's the period? 180 degrees. So here's a formula, right? This is A, this is B. So the period is equal to 360 degrees divided by B, or if it's in radians, 2 pi divided by B, right? And that formula, period is 2 pi over B, is on your formula sheet. Just have to go and verify it. But the formula, period equals 2 pi over B, is on the formula sheet. Okay? Which means that they're more interested in dealing in radians than in degrees, right? But, we know degrees, so it's not going to hurt you to see them a little bit. This one, y equals 1/2. Again, that's A, that's B. What's the equation of the midline? Y equals 0. What's the amplitude? 1/2, right? 1/2 or 0.5, which is your A value. What's the period?
Pi over 2.
Yeah, so we complete one cycle when we hit pi over 2. Okay, now remember, period is equal to 2 pi over B, which in this case is 2 pi over 4, which simplifies to pi over 2. Right? 2 over 4 is just 1/2, right? 1/2, so pi over 2. Questions? comments, concerns? Moving on. Y equals 2 sine x plus 1. What's the equation of the midline?
2.
Y equals 1.
How am I not getting this?
What's the amplitude? 2. What's the period? So we're looking at how long does it take to complete one cycle? 2 pi. So A is equal to 2 and A is the amplitude. D is equal to 1 and D is where the midline is, right? At 1 or up 1. The B value here is 1, meaning we just get 2 pi over 1, right? Remember, period is 2 pi over B. 2 pi over 1 is 2 pi. So you just get a regular normal period.
Where does C go?
No C.
Oh.
Oh, say there's no C.
Okay.
Why is there not?
Why is it? Because there's no, well, C is 0.
Oh.
Okay, this is a cosine function. We're going to look at this a little bit and then just forget we ever saw it, right? So a cosine function is really just a sine function that's been shifted, right? It's just been pushed over. So, because if you look here, you can say, well, okay, look, this starts going up here, and then we know that it's going to do this, or it's going to keep going. So it's really just a sine function, but instead, the cosine function starts at the top, goes down to the middle, goes down to the minimum, comes back to the middle, and then back up to the top, and that's one complete period. So period, really, when you're looking at the period, it's from any point on the graph to where the graph repeats itself. Okay, so you don't have to start here. You could say, well, I'm going to start here. You know, we would just need a little bit more. Okay, so here it's easier just to say, well, it starts at this point, and when we get back there, we'll have gone through one period. What's the equation of the midline?
0.
Y equals 0. Okay, so remember, it's an equation. I don't know how many half marks I had to take off yesterday for not writing y equals. Ask you to write an equation of a line, it's got to be y equals, not just, you know, an expression. You're very expressive, but you're not very equation oriented, right? It's like, I can get the expression right, but you want to write it as y equals. What's the amplitude? And what's the period? Okay, now remember, that's degrees. We're not really going to do much in the way of degrees. We're not really going to do much with the cosine, but, you know, it's good to see them. Especially seeing as a large number of you are planning on doing 30-1, and you will be seeing a lot of the cosine graph. Okay, so, you know, it's more valid to introduce it now because you're going to see a lot of it in dash 1. So if we compare sine and cosine function, okay, we can see that really if you just take this function here and shift it over, you know, then it's just going to lie on top of that one, right? So they're really just a phase shift away. What's the equation for the midline of both of these guys? Y equals 0. What's the amplitude for both? What's the period for both? Okay. What's the y-intercept for cos x? And I guess I should label it. This is y equals cos x. This is y equals sine x. What's the y-intercept for cos x? What's the y-intercept for sine x? What translation is performed on cos x to get sine x? What do you have to do with this guy? You have to shift it over. It's actually going to be 90 degrees based on the, so 30, 60, 90. If you shift it to the right 90 degrees, so shift right 90 degrees. Okay, and again, you're going to go into a whole lot of detail on this in a dash 1 course, and we're just kind of overviewing it here in dash 2, right? So, summary. What's the domain of sine and cos? Yeah, x belongs to the reals. There's no number that you can't put in, right? You can find the sine of any value, any x value, right? Be it in degrees or radians. What's the sine of a billion? You just punch in your calculator, it'll give you what the sine of a billion is, right? What is the range? Okay, both functions go from -1 to 1. What is the period? Or, and this is more important for you, what's the period? Degrees. Radians, what's the period? 2 pi. What's the midline? What's the amplitude?
1.
Yeah, sine has an y-intercept of, and cos has a y-intercept of 1. And what we're going to do now is, given a graph, let's look at the graph and state the characteristics. So state means you don't have to show any work, right? You're just saying this is this. So why don't you do these, right? You got time. Take a minute, work your way through. You know all the stuff, right? So you know all the lingo now. You've got 4 graphs to do. You've got 5 graphs to do. Yeah, 5 graphs. So do these 5 graphs. Get all the characteristics of them. Write them out. I will do the same. I'm just going to pause this now. Go. Okay, so here.
Yes, it's on the recording.
Oh, okay, go. So there are the characteristics for the first 2 graphs, and now I will pause, slide down a little bit, and we'll do some more. Go. Nobody knows. Alright, so here's 3 and 4 answers. For the people in the hall, you can watch this later tonight. It'll actually be today's lesson recorded live and in person. In room 322 on the 3rd floor. Okay, so there's the last one. It's a cosine function, but what's the difference between a sine function and a cosine function? Basically the phase shift, right? It's just the horizontal translation. So one starts at the middle going up and one starts at the top. And if you're at the top, you have nowhere to go but down. So one starts at the top and it goes down. For us, we're basically not going to have anything much to do with the cosine function. But for those of you going to 3-1, you will be learning a lot about the cosine function. And positive signs and negative signs. Yep.
Is that today's lesson?
Nope.
Are we doing the whole thing?
Yep. That was an event.
That was the train at Heritage Park.
It says, hey, you are supposed to time the junior football game at 4:30, so you better remember that. It's my 2-hour warning.
Have they been playing good?
They've been playing well. Okay, so graphs of sinusoidal functions continued. Given y equals a, sine bracket b x plus c plus d, the equation of the midline is y equals max plus min divided by 2. It's the average, right? If you think of a midline, it's in the middle. What's another name for the midline? Median, right? So, or median, which I think they just stick in the middle of roads so that we can't turn where we want to, and we have to go like 6 blocks out of the way and then come back. Yeah. As long as there's no police officers around, because I think that's illegal. Okay. So the equation of the midline is written y equals, the value of d is the exact same number, right? So whatever d is equal to, so if d is 5, then you would say the equation of the midline is y equals 5. Where we use these is, if I give you a graph, and from the graph you can get the max and the min, then you can plug it into here and figure out where the midline is. Now, keep in mind, the only formula you get is this. Period is 2 pi over b. You don't get any of that. Oh, I think you also get this. So you are given 2 formulas for trig. One is y equals a sine bx plus c plus d, and the other is period equals 2 pi over b. The amplitude, or the distance from the midline to either the max or the min, so max minus min is how far apart they are, right? Like if one is at 10 and one is at -5, how far apart are they? Well, they're 15, right? 10 minus negative 5 is 15. So if you take max minus min, you'll always get a positive number. Divide that by 2, you get the amplitude, which will always be a positive number. Keep that in mind for 30-1. It's not a distinguishing characteristic in 30-2 that you need to know that, but in 30-1 you need to know amplitude is always positive. And if you're given a graph, you can just count the amplitude. So generally, if I get a graph, the first thing I do is draw the midline in. Right? That then gives me the equation. I can write y equals. It also gives me the value of d. I can say d equals. I can go from the midline and count to the maximum, and then I've got a. So now I can write a equals. So a and d are very easy to get, right? You just read them. You can read them out of the equation, obviously, and then they're easy to get because there they are. But you can get them off the graph quite easily, right? Period. You can get that off the graph by finding a point and then going through one complete cycle and getting back to that same point. It's the length of the interval of the domain to complete one cycle, or the length of one cycle. If you're given the equation, so if you know the value of b, you can calculate the period, right? Just go 2 pi divided by d. We generally are not going to be using degrees. We will almost always use 2 pi. Keep reading, right? We will almost always use 2 pi over b. The start point of a sinusoidal function is where the graph intersects the midline and is first going up. So that's called the start point. So if you get a graph that looks like this, and here's your midline, and you're looking at this, this is the start point. Okay? So what you want to do, you draw in the midline, and then you just go along the midline, either left or right, and you say, okay, where's the closest point? Start at the y-axis and end the midline, and just say, where's the closest point where this graph hits the midline and is going up? Okay, bless you. And that will be your start point. Now, we use a little magic or hand waving here to get the start point. If you do 30-1, you're going to look at it in a different form. Okay, so this is just a shortcut we use in 30-2 because this is the only transformation that we do. Whereas 30-1 is like nothing but transformations. And so you'll look at a sinusoidal function from a slightly different way. Now a is always a, d is always d, b is always b. The start point always depends on c, right? And that's the only difference between the two courses as far as the letters go. All right, mostly in 30-2 what we're interested in is applications of the sine function. So here's a Ferris wheel. The graph below represents the height of a person on a Ferris wheel over time. The person gets on the Ferris wheel at x equals 0. So at time 0, they get on the Ferris wheel, right? And they're the last one on. Okay, and then it starts up. And you don't have to go through like a loading cycle, right? Where it's like, and then Ferris wheel. Unless you've been on the London Eye or anything, that's a continuous loader, right? Wait, and I know at least 4 people in here have it. The London Eye is a continuous loader, which means it just keeps moving, and because it's going at such a slow speed, you just kind of walk on, right? And that's fairly easy. You can load a lot of people. Have you ever been on the Ferris wheel at Stampede? And then they load like 4 of it's the one with the round cars. They load like 4 groups of 6 people, and then rotate around. So it takes a while before you can start the ride. Anyway, so this graph, the height is in meters. So how high is this Ferris wheel?
85.
Well, we got to figure out the scale. 72, 73, 76, 74, 76, 78, 82. So 82 meters, right? So let's make a note here that the max is equal to 82 meters. What's the minimum height of the Ferris wheel? 2. Why is it 2 meters?
Because you're not right on the ground when you're.
It causes a lot of damage to the ground.
Yeah. Okay, you ever been on the one at Disneyland and California Adventure? Because that one loads below the ground, right? Yeah.
Wait, what?
So it goes kind of underground level to that way they can have people kind of go down into a shady area and then load on. But this one, any portable Ferris wheel is always going to load above the ground, right? Because they're not about to dig a ditch to put it in and that. If you have a permanent installation, then you can say, hey, we're going to have this thing go below ground to load, and yeah, it's just a decision. So this one, we have a maximum height of 82, a minimum of 2. So A, what is the height of the Ferris wheel when the first person gets on it? 2 meters. You can read, I just can't speak. What is the minimum height of the Ferris wheel? 2 meters. What is the maximum height of the Ferris wheel? 82 meters. What is the equation of the midline?
40.
So we need the average of these two numbers, right? So midline is equal to max plus min over 2, which is 82 plus 2 over 2, which is 84 over 2, which is 42. So the equation of the midline is y equals 42 meters, and the value of d is equal to 42, right? So what we're going to do basically is, from the graph, we can determine the equation, right? We can figure out what's the equation. How do we get that? Well, you got to figure out what d is. Okay, we just did. You got to figure out what a is. So how do you get amplitude? So the amplitude is max minus min over 2. Right? So what we're saying there is it's half the distance from max to min. Max minus min gives you the difference from the max to the min, and then you divide by 2. So this is 82 minus 2 over 2, which is 80 over 2, which is 40. So the amplitude A is equal to 40, but it has units, right? It's 40 meters. So sometimes when we look at the sine function, we just, hey, here's the sine function. Its period is 2 pi, and its amplitude is 1, and its minimum, and the numbers have nothing to do. They're just numbers on a grid. Here, the numbers are, hey, what's the height? What's 2 meters? What's the amplitude? 40 meters. What's the radius of the Ferris wheel? What's the radius? Okay, what is the definition of radius?
Half of the midline that are outside.
No, we have different words for it, so they don't actually mean the same thing. Distance from the center to the edge, okay? What does that correspond to on the graph? Hang on, whilst I pause. Okay, so the amplitude, right, think about it. It's the middle, right? From the midline, which is at 42, you go up 40, you go down 40. What's in the middle of the Ferris wheel?
Probably a turning axle.
The axle or the hub, right? And then from there you go up to the top and you go down to the bottom. How far? Well, the amplitude. Okay? So the amplitude of the sine function is the radius of the Ferris wheel. So it's the amplitude. Which is 40 meters. All right, so what we're doing is we're taking a sinusoidal function. Well, we're taking the graph of a sinusoidal function. From this graph, we can actually get the equation. So we're going to figure out the equation, and then we can graph it. And we can see if we get this graph, right? We should be able to get this graph. We should be able to set our calculators to this window with this scale, put in the equation that we think it should be based on our values of A, B, C, and D, and graph it and say, hey, yeah, it's the exact same graph, right? What is the height of the person after 1 minute? Okay, now what's this measured in? I think it's minutes, right? Okay, so after 1 minute, we are at 40 meters. Okay, so you just look on the graph, you find 1, up to the graph, across, and we have 40. So the height after 1 minute is 40 meters. How long does it take for 1 revolution of the Ferris wheel? Okay, 1 period, 4 minutes. So a period can be measured anywhere, right? In this case, it's from a minimum back to the minimum. 0 to 4. From a maximum back to the maximum, 2 to 6, which is 4. From when you first hit the midline going up to when you hit the midline going up again, 1, 2, 3, 4. How long does, we did that, right? 4 minutes. Okay, so here's the thing, right? A and D, right? The amplitude and the midline deal with stuff that's happening on the y-axis, right? So they're in y-axis units. So the midline and the amplitude are measured in meters because the y-axis is in meters. B and C, and we're not quite getting to C yet, but B and C deal with stuff that's happening along the x-axis, right? Like the period, how long? 4 minutes. Okay, the start point, well, that occurs after 1 minute, right? We're going to hit the start point, which is here, in 1 minute. Okay, now that's not really our, our start point is kind of down here, but when we define a sinusoidal function, I always like to sketch in the midline, which is where? 40, 42? 40, right, okay. So I always like to sketch in the midline because then I can see stuff like, hey, here's the starting point, right? What's period? So what's the period of this function? Period is 4 minutes. Okay, so these guys are the same. The time for one revolution is actually the period of the graph. What is the value of B? So period. So here's the things, right? A and D are the nicest numbers because you can read them right off the graph, right? You can just say, hey, here's the max, here's the min, get halfway in between, there's D. Here's the distance from the midline to the max, or max minus min over 2, that's A. B isn't the period, but B can be used to calculate the period. So we know the period is 2 pi over B. So for us, that's 2 pi over 4. Oh, sorry. It's asking for the value of B. Hang on, start over. Period is equal to 2 pi over B. That's at least true. Rearranging this equation, I get B is equal to 2 pi divided by the period. The quick rearranging is just interchange these two. Think of that over 1, cross multiply, divide, whatever, right? Anyways, wave your hands. This is what comes out. Which for us is 2 pi over 4, which is pi over 2. So the value of B will be pi over 2. I should have said the value of B is pi over 2. What's next? Got to be something to do with the start point. What are the coordinates of the start point? This is why you want to draw the midline in, right? So you could say, okay, these coordinates of the start point is 1, 40. Right? 1 minute, and the start point is 40 meters, right? Definition of start point, it's 42, you're right. So, okay, this actually is 142. 1, 42. Okay, so the start point is at 1 and 42, and this height of the person after 1 minute was 42. It was 42. Trust me. Go back and look. Coordinates of start point are 1 and 42. What is the value of C? Okay, now what I will give you on the test is I will give you the formula and I will say start point is negative C over B comma D. You don't get that on the exam. You're only going to get like 4 sinusoidal questions, maybe 5 on the diploma. And they're not going to ask you anything to do with C. I will. I'm not going to ask a lot, but I'm going to ask like 1, maybe 2 questions that involve C. But I'm going to give you this formula. Start point is negative C over B. So now you get to say, okay, that means that 1 must be equal to negative C over B. But we know what B is, because we just figured it out. What's B?
1.5 pi over 2.
Yeah, do not go to decimals, ever, never. Leave it as pi over 2. So what happens when I divide by a fraction? you flip it, right? So it's c times pi over 2. So c divided by pi over 2, wait, you gotta flip it.
That's so weird.
Hang on. Control Z. Control Z again. What happened?
Broken.
Looks like. Okay, so this is 2 over pi. So dividing by pi over 2, we kiss and flip, multiply by the reciprocal. So this says 1 is equal to c times 2 pi. Multiply both sides by pi. Divide both sides by 2. So c is equal to pi over 2. Only wait, it's a negative. So that's a negative, and that's a negative, and that's a negative. So c is negative pi over 2. One question. I want to give you one question that deals with c. Okay? Not going to be a lot, just one question. On the diploma, no questions deal with c. Trust me. So the value of c is equal to negative pi over 2. What's the equation of this? So now we can put it together, right? The equation is y is equal to a. What's a? 40? Sine, what was b? Pi over 2. X minus pi over 2, right? Because it's plus c, which is pi over 2. Let me clean that up. So minus pi over 2 plus 42. So we should be able to take our calculators, which I don't have open. So we should be able to take our calculator, put this into the equation. So hang on. It's a stupid Microsoft Ink thing. That's good. Did you all hear that? Somebody said, "Oh my God, it works!" Well, or words to that effect. I'm trying to find my calculator still. Here we go. 284 plus e se. What do you mean? Oh, see, there it is down there like that. And okay. Where are you? It's not responding. The wabbit is... Okay, so on, clear. Make sure your calculator is in radian mode, which should be easy because it should be in radian mode. We are going to, let's go set the window to match what we have back here. Up here. Down here. So I want my x's to go from like -1 to 9 by 1s. I want my y's to go from like -6 to 84 by, we'll go by 4s because by 2s would be. Okay, so from -1 to +9 by 1s. From -6 to 84 by, let's say, 4s. Our equation is y is equal to, what was A? 40 or 42? 40 sine pi over 2, so let's throw in a bracket. Pi divided by 2 bracket x minus, let's throw another bracket. Pi divided by 2, close bracket, plus 42. Okay, so we took a diagram. From the diagram, we figured out the midline and the amplitude. That gave us A and D. We figured out the period. We read the period off of the graph. We used that to calculate B. We found the start point. We used that to calculate C. We think this graph should look like this graph. And I'd say it pretty much does. One thing I like to do is I also like to graph the midline. It's nice if you can see the midline, right? Because it gives you, and then we can say, well, hey, let's find this starting point, right? So second calc, intersect, and let's go this way. Actually, let's go to there and then move along here. And go 1, 2, 3. And we'd see 142. Hey, yeah, that matches up with what we said the start point was, right? 142. And, if you found the maximum, you would see that it appears at 2 and 84 and so on, right? So we can take a graph, calculate A and D. I do D first, so calculate D and then A. Figure out the period from the graph, use that to calculate B. Get the start point from the graph, use that to calculate C, and generate the equation. Okay, tidal depths. In Inverdeen Harbor, the maximum depth of water is 22 meters, occurring at 1 a.m. and 1 p.m., as shown on the grid below. So we actually have dots there. The minimum depth of the water is 6 meters, occurring at 7 a.m. Okay, so 6 meters at 7 a.m. And what's 7 p.m.?
Wait, let me do the math.
19.
Took a while, 7 plus 12. Were you using your fingers? I ran out of fingers. I got as far as 17. I had to stop.
I got my own way of figuring it out. It's all complicated.
Okay, I actually know that 7 is, because my watch is set for 24-hour clock. So right now it's 14:54. The depth is 14 meters at 4 a.m., 4 a.m., 10 a.m., 4 p.m., I'm going to spare you calculating it, that's 16, and 10 p.m., that's 22. Assume that the relation between the depth of water, y, in meters, and time t in hours is a sinusoidal function. On the graph, in which t equals 0 at midnight, plot the key points listed above, so we've done that. Connect the points to form a sinusoidal function. So we know that our minimum is 6, our maximum is 22, our midline is going to be 22 plus 6, which is 28 divided by 2 is 14. So D is equal to, let's just say mid. Sheesh. All right, it's down the page. Okay, D is equal to max plus min over 2, which is 22 plus 6 over 2, which is 28 over 2, which is 14. So the midline is y is equal to 14. So let's graph that. Let's do it in a different color. Y equals 14. Okay, so there's your midline. Our amplitude, A is equal to max minus min over 2. Or you can just count, right? Just go 2, 4, 6, 8. So you can count, or you can do max minus min. So 22 minus 6 over 2, which is 16 over 2, which is 8. We need to draw this. So I'm not really sure what's going to happen here. So let's just start here. So we're going to go, remember we're divided into 4 parts, right? So from the maximum to the midline to the minimum, and I just want to draw this as a nice curve.
Oh yeah, that's extreme.
Okay, which means this is just going to turn around and come back that way a little bit. And this really needs to be a titch higher over here. So I'm just going to clean that up. Should do this. There we go. Don't worry, I will be very forgiving of your sketches on the test. But what I want to see is, I want to see these points. Okay? And then draw something that looks like it. Do not draw this though. You may not draw a sawtooth. You can't draw a V, right? You do have to at least round the bottoms. Okay? So it's not a sawtooth curve, it's a sinusoidal. It needs to be smooth. Okay, what have we done? Connect points. Calculate the midline amplitude. Done. State the period. What's the period? Okay, so you can go from here to here, which is from 1 to 13, so it's 12. Okay, so period is 12. 12 what? 12 hours. Okay, remember the x value is in hours, the y value is in meters. We're losing Ryan. Oh, it's back. Tired. Go to bed early. Practicing too hard. I'm gonna burn you guys out before the big game. Okay, so the period is 12 hours. What's the start point? Where is the start point? Okay, start point at the midline going up. So I'm just going to start here, go along the midline and say, okay, there it is at 10 and then 14. So the coordinates are 10, 14. That's the start point. The equation could be represented in the form y equals a sine b bracket x plus c, which is a slightly different form of the equation. Write the equation in this form. I'm going to do that. We're going to change this. Just make this bx plus c. Okay, so the a value is 8. Y is equal to 8 sine bracket b. What's b? Okay, so b is equal to 2 pi over the period, which is 2 pi over 12, which is, and don't get anxious, just go pi over 6 because it's exact. Don't actually go 2 pi divided by 12 and then spew out a decimal, right? We don't want that. We want the exact value for b in terms of pi. So it's pi over 6x bracket plus d, which is 14, so plus 14. We now have to figure out c, right? C is always fun. So the start point is negative c over b comma d, which means negative c over pi over 6 is equal to 10, right? Because that coordinate is, right, this is 10 comma 14. So negative c over b, and b is pi over 6, is equal to 10. Okay, we can change that to negative c times 6 over pi is equal to 10. Multiply both sides by c. Negative 6c, or sorry, by pi is 10 pi. And so c is 10 pi over negative 6, which is negative 5 pi over 3. Don't worry, I'm only going to ask you one c. Yeah. So c is equal to negative 5. Won't even fit there. C is equal to negative 5 pi over 3. We should now be able to go to our calculator, enter this window, enter this equation. I don't know what order you want to do it in. So let's go enter the equation. Well, I'm just going to clear these guys out. Clear. Okay, so it's, go up here, 8 sine bracket pi divided by 6 bracket x minus bracket 5 pi divided by 3 bracket bracket plus 14. I'm also going to graph 14, right? Just because I like to graph the midline. Yep. C helps you find the start point, but it doesn't stand for anything. A and D are the only ones that actually stand for something. A is the amplitude, D is the midline, B is used to calculate the period, and C is used to calculate the start point.
Like, can't we just, like, look at the start point and tell them where it is?
No, not easily.
But didn't you say it's whenever it starts going up?
Yeah, you can get the start point, you just can't get the value of C easily.
I said C is the start point.
No, C is used to calculate the start point.
Okay.
Don't worry about it. Are you planning to do 30-1? Lucky you. Okay, so you don't have to worry. if you're doing 3-1, then it really does look like this. B bracket x plus c, and then c is really the phase shift, right? It's a left or right shift. But you'll learn all about that at the time you need to, which isn't right now. Okay, so if we set our window to match this, right, say let's go from 0 to 24 by, let's say, 2's. And what did this do? Went from, let's say, -2 to 24. So -2 to 24, also by 2's. And then hit graph. And then put this back. And put that back. Put this here. So then these graphs should match. Okay. Now you could figure this out, right, by seeing, is that 10, 14? I sure hope so. Oops. Yeah. Okay. So there you go. Nice exact match. All right. So what's actually important right now? In part A, match each graph with one of the equations listed. So go through this and figure out, okay, what do I know about this thing? Like, what's the amplitude? So what I would do first is just basically look at an amplitude. After the amplitude, look for the midline, right? So if you say, hey, the midline is 1, then that means it's either this one, or this one, or this one, right? Like that characteristic takes you down to it's one of these 3. Then you look at the amplitude, now you say, okay, now it's one of these 2. So, okay, let's do this first one. So the midline is 1, meaning it's either this, or this, or this. The amplitude is 1, 2, meaning it's not this one, so it could be this, or it could be this. So is it a sine? Well, it starts at the midline going up, so it's that one. Right? Remember, a sine curve starts at the midline going up, a cosine curve starts at the top and goes down. Okay, so use your matching skills. Take it back to like elementary school, right, when you were matching stuff. Matching questions. And then there's nothing after that. So okay, so just match those, then we'll go through the answers. So I will pause while you match. Okay, so midline of 1, amplitude of 2, sine function. This is B. Midline of 1, amplitude of 1/2. A. There's also a period of 1080, but midline of -2, amplitude of 3. So it's either this or this. It's a sine. So F. And midline of 1. It got cut off. Is this on your sheet? Does it go down to 5?
Yeah. Mr. Yanover.
Yeah.
H.
H?
No, it's that.
Oh, okay, wait a second. So these two are the same except for the period, right? So this period is 2 pi over b, 2 pi over 2, which is pi. So does this have a period of pi? Yes. So it is h. And then this one is a cosine function where d is -3. So that pretty much makes it e. Okay, and that's that.